today. Lesson 10 talks about a couple different things. This Algebra 3 Lesson 10, we're going to talk about the equation of a line. We have rational denominators, and we have completing the square. So we have three big sections in this. So we're looking at question number 1. It says write the equation of a line that passes through the points -2, -8, and is perpendicular to 5x equals -8y plus 6. So this is what I would do with this, is that just because I think at this point this might be how your brain works, it's certainly how my brain works, is I'm looking at here and I've got x on one side, I've got -8y plus 6 on the other side. I want to get this equation into slope-intercept form, right? So that's y equals mx plus b. That way I can see what my slope is. We should understand some of that, right? Okay, so I'm going to get positive 8y equals -5x plus 6. Do we understand how we did that? Okay, switch the x and the y by addition and subtraction. Now I'm going to divide by 8. Okay, so I have y equals -5/8x plus, let's see, that's going to be really 3/4, right? Okay, so that is the equation of this line. Okay, so we want to write the equation of a line that passes through -2, -8, and is perpendicular to what we have here. So let's see, if we're going to write an equation of a line that's perpendicular, I have to work with a different slope, correct? Okay, so the perpendicular slope to the slope that I have is an opposite reciprocal slope. So if my slope is -5/8, what's opposite reciprocal to that? Positive 8/5. So I need to work with 8/5, and it needs to go through -2, -8. Okay? So what we're saying then is -8 equals 8/5 times -2 plus b, because we don't know what our y-intercept is, do we? Okay, so we're solving for b, correct? All right, so we've got 8/5 times -2, which is going to be -16/5, right? Yeah. All right, so we've got -8 equals -16/5 plus b. So what we're going to do is we're going to take -8 and we're going to add 16/5 to it. Okay? So kind of make my life a little simpler here. -8 plus, is somebody keeping track on the time? Yeah, if you got to go, you got to go. All right, that's giving me -4.8, which is -24/5. So the equation of my line is y equals 8/5 x minus 24/5. Now, the answer that the book comes up with for this is equivalent but different. Okay, just so you're aware of this. If I take this whole thing and multiply it by 5, okay, that's going to give me something that's going to look a little bit different. All right, thank you guys for being quiet on the way out. Does this make sense as what we've covered here? Okay, if we switch it to y-intercept form, okay, we got our opposite reciprocal slope. We plugged in our x and y into that, solved for b, then plugged everything back into our original equation with the slope that we needed and the y-intercept that we needed. Okay. Okay, number 2, find the equation line that passes through 2, 6 and is parallel to this line. Okay, in that case, we're going to keep the slope, right? And then we'll interject our numbers in. Let's see, I want to see if there's maybe a little bit quicker way into this. There's not anything that I'm necessarily seeing. No, because we're not working with that. Okay, so here we've got 4x plus 4y equals negative 1. Because here what I'm looking at is I'm looking at a list of answers. So I'm going to hit pause for a second. All right, do you guys want to see one more of these, or do you want to move on to the next thing? I need like a cricket sound going on here. Do you want one more? All right, and that's fine because 2 and 3 they're the same, right? All right, so if we look at this, I've got 4x plus 4y equals 1. Gosh. All right, so I would get 4y equals negative 4x minus 1, right? If I'm starting to convert this over to slope-intercept form, divide by 4. Okay, so I get y equals negative x minus 1/4, right? Okay, so my slope here is negative 1, or negative 1 over 1, right? But what I'm working with, right, is I'm working with a parallel slope, correct? So my equation is y equals negative 1x plus b, right? What we can do is we can plug in our 2 and our 6, so we get 6 equals negative 1 times 2 plus b. 6 equals negative 2 plus b. Add 2, so I'm going to get 8 equals b. So my equation then is y equals negative 1x plus 8. Okay, it's going to be an equation that'll go through there, through that point, and will be parallel to my slope. Okay, does that look like it works to you? All right. Your answer for number 3, just so that you're aware, so if you look at it, you can make sure that you get the same answer, will actually end up being B. They leave these in standard form. So, for instance, what was our answer on the other one? It was y equals negative 1x plus 8, right? If I wanted that in standard form, we would be getting, let's see, we'd be getting we'd be getting x plus y equals 8, really, for all that's concerned. Let's see. Yeah, and in this answer, what they gave was 4x plus 4y minus 32 equals 0. Anyway. Okay. All right, let's look at number 4. This stuff down through here is what we want to spend some more time with. Okay? Because this is where we're talking about rational denominators. And we've dealt a little bit with this with Algebra 2 when we have a denominator like what we have down here. In order to get it to where we're dealing with something that's rational, for instance, when we would have a radical in the denominator, we'd multiply by that radical over that radical, right? Okay, but here we're dealing with imaginary numbers or numbers that have more than one radical and those types of things. So if we want to simplify, all right, we're going to have to do something a little different. All right, which means, let's see. First off, let's simplify the numerator. Let's look at that. Negative 3 plus 2i minus 2i cubed. The negative 2i cubed can be simplified, can't it? Okay, because what we have is negative 2i times I times I. All right, what can be broken down there? What can I do away with? This I squared here, correct? All right, because that's negative 2i squared, right? Well, what's I squared? So that's negative 2 times negative 1, right? Times I. So negative 2 times negative 1 is positive 2, leaving me with a positive 2i, correct? Okay, so really what I have is I have negative 3 plus 2i plus 2i. Now I can simplify that, correct? All right, that leaves me with negative 3 plus 4i. That's my numerator now. Okay? All right. So I'm going to go ahead and erase this work, and I'm going to put that answer up here so that I've got it. Again, all of this is being recorded, so if you don't remember how to get there, go back and watch. Negative 3 plus 4i. Okay? All right, now what we have is we've got this denominator of 2 minus I, and this, a lot of people stop here, right? We don't know what to do next. Well, here's what we do next. I don't know if you'll remember us doing this with other things or not, but we're going to multiply by the conjugate. Does that phrase vaguely does something for me? Okay, that means I'm going to take the denominator, and I'm going to multiply by the denominator, but not exactly the denominator. I'm going to multiply the conjugate. The conjugate means that I keep everything in the same order, but I change the sign. Okay, so where there was subtraction, now we're doing addition. And what this creates is it creates a situation where whenever I FOIL, right, I've got some things that are going to cancel out. Okay? It's what is called a sum difference. But I'm also going to do that on the top. So I'm going to FOIL twice. Okay? So I've got negative 3 times 2, which is negative 6. I've got negative 3 times I, which is negative 3i. I got 4i times 2, which is positive 8i. And then I've got 4i times I, which is 4i squared, which is 4 times negative 1, which is negative 4. Okay? Now, I can simplify two sets of terms there. I have like terms, but I'm going to hold on to that for a second. I'm going to come down. I'm going to FOIL the denominator. So 2 times 2 is 4. And because it's a sum difference, I only have to multiply the first terms and the last terms. Okay? I don't need the outer or the inner. All right, so I'm only, because what's going to happen is I'm going to get 2 times 2 is 4. I'm going to get 2 times I, which is 2i. I'm going to get negative I times 2, which is negative 2i, and those things are going to cancel. Right? Then I'm going to be left with negative I times I. That's negative I squared, or negative 1 times I squared, or negative 1 times negative 1, or positive 1. Okay? Do you see how many things happen all at once? Because certain things are other things. All right? And it's easy to get lost in all that. So if you need me to draw and write all of those little steps out, I'll do that for you, okay? Do I need to go back and show you any more of the denominator? Okay, so let's come back up to the top. We've got negative 6 minus 4, which is going to be negative 10, and plus 5i over 5. And this will reduce, right? Negative 10 divided by 5 is negative 2 plus I. And that's your answer. That's what it all reduces down to. Okay? All right. I'm going to clear that out. Hopefully we've got that. I'm sure we want to continue to do some more of these, right? All right, now number 5 doesn't include any imaginary numbers, but it does include radicals. And so our step is we're going to jump right to multiplying by the conjugate. So we're going to jump straight to, 2 radical 2 plus 2. We're going to multiply by that. Okay, 2 radical 2 plus 2. Okay, and we're going to deal with that FOIL. Okay, so let's deal with it one step at a time. Don't take it too far. Okay, 2 times 2 radical 2 is 4 radical 2. Okay, 2 times 2 is 4. Okay, 2 radical 2 times 2 radical 2. This is where a lot of things happen at once. 2 times 2 is 4. Radical 2 times radical 2 is 2. 4 times 2 is 8. Okay? All right, so we've got that. And now I have 2 radical 2 times 2, which is 4 radical 2. Okay, and we can combine terms up there, but we're going to jump down here to the bottom, where we're going to do 2 radical 2 times 2 radical 2. We've already done that. We should already know that that answer is 8. Right? Okay, we should know that that answer is 8. And then we're going to do negative 2 times 2, which is negative 4. So as I come out over here, 8 minus 4 is 4. Okay, I've got 4 radical 2 plus 4 radical 2, which is 8 radical 2. And 4 plus 8 is 12. And both those things will divide by 4, so that I'm getting 2 radical 2 plus 3. Or, yeah, you can do it the other way around too. You could do 3 plus 2 radical 2. Was that too much? Now, some of you guys have to go, right, to go get your pictures taken. Okay? All right, which means I'm going to pick up with the one guy I've got in the room right now. Okay. So the thing to remember is that what you've missed has been recorded. But we're going to pick up on number 6. Let's see. Actually, what I'm going to do is, because what you see with number 6, what you see with number 7, those things are pretty well covered in questions 4 and 5. And because we're out of here at 11:24, what I want to do real quick is, if I can, I want to talk about completing the square. What's that? Okay, so we're going to skip down to number 8 real quick. Make sure that we've got, you're in here, so get your books out. Okay, we've got negative 3 plus 3x squared equals negative 4x. The first thing that I've got to do to this is get it in, gosh, I don't even have an answer for her. Yeah, I do. Okay, so we only have 9 questions. That's all right. I think that's all we've got. All right, the first thing I've got to do to this is get everything in order and get it all set equal to 0. Okay, so 3x squared plus 4x minus 3 equals 0. Okay, you with me so far? Getting it kind of set towards the quadratic. Okay. The next thing that we're going to do is we're going to add this 3 over here. So I'm working with 3x squared plus 4x, and I'm going to leave a blank spot there. Okay? The next thing I'm going to do is I'm going to take this term, the b. I'm going to take 4 divided by 2 and square it. So I'm going to always take whatever this number is, I'm going to divide it by 2, and I'm going to square it. All right? And I'll always come up with a positive number. So 4 divided by 2 is 2. 2 squared is 4. So I'm going to take that number, I'm going to add it here, and I'm going to add it here. Okay? So what I wind up with is I've got 3x squared plus 4x plus 4 equals 7. Now, these actually don't work out very well for this, but go ahead. Which 4? We just talked about that. I literally just did that. Look, you take this number right here, you bring it down here, you divide it by 2, and you square it. What's 4 divided by 2? What's 2 squared? I put it here, and I put it there. Okay? Now, unfortunately, what you're getting in here is you're getting into something which I don't like the way that they do these completing the square questions, because it doesn't lend itself towards factoring. Okay, 3x squared plus 4x plus 4 doesn't lend itself to be factored. In the end, what you see with something like this is that what you could just as easily do to solve this, rather than complete the square, is to solve using the quadratic formula, which is to take, negative 4 plus or minus the square root of 4 squared minus 4 times 3 times negative 3 all over 2a. So they pick really poor questions to solve by completing the square, to actually complete the square, when what you can inevitably use is the quadratic formula, which I think everybody in here should be familiar with, right? And what 2a, it would be what, 2 times 3? So we'll show you that we'll get the right answer, we'll get the answer that we should get. All right, so we've got 16, let's see, it would be what, plus 36? 16 plus 36, something like that. All right, what's 16 plus 36? That would be what? Is that 40? Is it 52? Okay. All right, so we've got negative 4 plus or minus the square root of 52 divided by 6. Okay. Let's see. You should be able to take the square root of 52, though, and reduce it. Like that'd be 2 and 26, 2 and 13. Right? So you could get negative 4 plus or minus 2 radical 13 over 6. So that's all going to reduce to negative 2 plus or minus radical 13 over 3 is what you get there. Like I said, I don't like these because they don't lend themselves easily towards actually completing the square to solve them. But if you want good illustrations on completing the square, page 79 does a good job of it. And you'll see some examples there that they use on page 79 and again on page 80. For instance, take a quick look over at page 80 because I don't want you to miss out on completing the square where it actually works out. Like on 10.6, you do this negative x plus 3x. We want to solve that by completing the square. So they have you write it in standard form, which is what we started out doing, right? Getting the 3x squared plus 4x minus 3, even though that's not the form that they gave it to us in. So we put it in standard form. We divide every term by 3 so that the coefficient x squared will be 1. So here there was nothing that I could have divided all of that by unless I divided it by a fraction to get what you want in this is you want a coefficient of 1. Well, I've got a coefficient of 3. You see what I'm saying? So I'd have to divide everything by 3, and so I'd wind up with x squared plus 4/3 x minus 1, but I would have this weird thing in the middle. See what I'm saying? But what you want is the steps from that page 10.6. So they divide everything there by 3, and they get kind of what we would have gotten. So you have to have that coefficient of 1. So let's show it being worked out just so that we know that this is our answer that we should get. Okay, let's see if we can get there. So we're going to divide everything here by 3. So I'm going to get x squared plus 4/3 x minus 1 equals 0. We're going to add 1 to the other side. Okay? So that's going to equal 1 over there. Now I'm going to take this 4/3, divide it by 2, and square it. Okay? Or multiply it by a half if you want. If you multiply it by a half, you're going to get, what, 4/6? 4/6 is 2/3, correct? So we're going to add 2/3 plus 2/3 there. Okay? So you always take this middle term, divide it by 2, and square it. Okay? And then from there, what they want you to do is what we would do is we factor that on down because you'll see next as we've got all that, then we add that solution, that we add that 2/3 to both sides. Okay, then we simplify and solve for x. Okay. Again, I'm not a big fan of the question, but we should get negative 2/3 plus or minus radical 13 over 3. Yeah. You could use the quadratic, right? And like I said, there's better questions than this one. I want to see if, and like number 9 in the practice here isn't really a whole lot better. Because I got a bunch of you guys back, though, I want to go back through one of these rationalizing denominator questions because you guys were gone for those. Okay, so what I want you to know is on these completing the squares, you can use the quadratic formula. That's that negative b plus or minus the square root of b squared minus 4ac all over 2a, right? Do we remember that? So use that is my suggestion. There are some questions where you do need to know how to complete the square later on, but not so much today. All right, let's look at number 6. I think we can get number 6 done. The first thing we're going to do is we're going to try to simplify this numerator as much as we can. And what I have here, if I need to, I'm going to look at it like this. Okay, because we've covered these i's before, but you may not directly remember. So anytime I've got two i's, that's a negative 1. So this would be negative 4i. Okay? Now anytime I have 4 i's, that's a positive 1. Okay, so this is just negative 5. And over here I've got, what? Negative 5 again, right? So this is really negative 10 minus 4i in my numerator. See how we took all of that and simplified it? All right, good. So we're going to hold on to that. Okay, and I'm going to shove it up here, negative 10 minus 4i, so it's out of my way. All right, now we're going to look at this. We've got 2 minus 2i plus square root of negative 16. The square root of negative 16 is something that can be simplified. What is the square root of negative 16? 4i, very good. Which means I can combine that with the negative 2i, right? Okay, so that's going to give me 2, and that's going to give me 2 plus 2i. Now, this is where you could probably do all of that, right? You could simplify all of that. The next step is the step that we're learning today, which is how do I rationalize that denominator? And we rationalize it by multiplying by the conjugate of the denominator. And the conjugate of the denominator is simply the denominator, but with the opposite sign in the middle. Okay? And now what I do is I FOIL the numerator and the denominator, and then I'll simplify them whenever I'm all done. So negative 10 times 2 is negative 20. Let's see, negative 4i times 2 is negative 8i, right? Negative 10 times negative 2i is positive 20i. And negative 4i times negative 2i is 8i squared, which is negative 8. Okay? You see how some things, multiple things are happening at once? Do I need to go through that last one again? Okay? Negative 8. Okay? And I'll come back to that here in a second. When you're rationalizing the denominator of these, they should always turn out to be a sum difference, which means I'm only going to multiply the first and last terms because the middle two terms are going to cancel out every time. All right, so 2 times 2 is 4. Okay, negative 2i, or sorry, positive 2i times negative 2i is negative 4i squared, which is positive 4, right? All right, so positive 4. So as we simplify, we've got negative 20 minus 8. That's negative 28. We've got negative 8i plus 20i, which would be what? Positive 12i over 8. Okay, can we simplify? Feel like Bob the Builder. Yes, we can. All right, let's see, what question was this? This is number 6. All right, so let's talk about negative 8 over 8. All right, so that's going to give me negative 14 over 4, right? Negative 14 over 4 would be negative 7 over 2. Negative 7 over 2. And what? 12 fourths, or sorry, 12 eighths. That would be what? 6 fourths, 3 halves. So plus 3. So it should be negative 7 plus 3i over 2. And it works because I get the same denominator. If I'd gotten different denominators, I would have had to split it. Okay? Does that make sense on how to do that? So that's rationalizing the denominator. I think we understand the whole, what is the equation of a line given this set of coordinates and it's parallel or perpendicular. I just need to check my slopes, plug my stuff in, solve for b. I'm thinking that we could probably use y2 minus y1 equals, mx minus x1. Those. I'm thinking that we could use that, but for whatever reason, my brain slipped, and I just kind of went back to kind of the old clunky way of doing it. All right, so hopefully we understand enough to be dangerous and get our homework done.